Hello! In this episode I will talk about things which might be rather complicated for people who didn't watch my movies before. So if you want to understand the subject, better pay attention. First, I need to speak again about the direction of field lines in the Interplanetary Magnetic Field, IMF. As I said before, the angle of field lines in the IMF depends on the direction in which the particles are moving. So in our case, they're supposed to be perpendicular to the x-dimensional axis. I found even a web page where it is confirmed. The solar wind magnetic field can be measured in three components: Bz, Bx and By. Bx lies along the Sun-Earth line, with Bz and By defining a vertical plane, the clock face. The solar wind clock angle is the angle produced from the vector sum of By and Bz. Just as I said before. Anyway, I need to disagree with this. The field lines are perpendicular to x-axis only when solar wind is calm. During a CME impact, the direction of field lines can vary. CME is a huge cloud of plasma, and the directions in which particles are moving don't have to always point towards Earth. However, SWMF monitors from ISWA are not capable to generate the IMF field lines at different angles than perpendicular to X. That's why I will use the CCMC visualization tool directly on their page. This monitor is much more sophisticated, but the readings here are much more accurate. On the XCAD view, we can watch the angle of IMF field lines. Because people from CCMC didn't still answer to my emails, and I've sent quite a lot of them, I've decided to make a small investigation, and it was worth. This table shows all the latest requests of SWMF model runs. There are two main types of requests, with modeled environment and those which show real events. Of course, I'm interested mostly in the second type. So let's look at some of the simulations. Some of the runs allow us to watch the pre-computed animations of magnetosphere. This one doesn't. Instead, I'll show you how many satellites send their data to render the new SWMF monitors from ISWA. So, next time when you will hear suspicious observers telling that the SWMF monitors are just simple toys for bored scientists, you will know how much you can trust his words. Anyway, let's look at some animations generated by the CCMC supercomputers. If you wonder why the densities are differing so much from the real-time readings, notice that on this image the value of n is not logarithmic. Maybe some of you noticed already that the field lines in front of Earth are not quite perpendicular to the vectors. You're right, but just wait for other images. For example, this animation is much more interesting. Look carefully, as the field lines are barely visible on the blue background. ZCAT view confirms it. Field lines are not perpendicular to the vectors of solar wind. According to the laws of electromagnetism, such a situation shouldn't be possible at all. This animation was made using the readings from 21st of March 2014. There is a visible angle between the velocity vectors and the field lines. This event took place on 15th of January 2012. On 1st of November 2010, we had an opposite situation. Field lines were perpendicular to X GSM dimension, but instead the vectors were pointing at Earth with a small angle. But now it's time to show you some really interesting images. Notice that the angles of those field lines are changing from the side of Earth. Again, some spectacular event. Again, the directions of magnetic components are changing from one side to another, instead from the front towards the night side. And this can be explained only when we will add a force which will influence the IMF from the side. Anyway, I've managed to find quite a lot of images where the IMF field lines are visibly tilted towards the X dimension. Some of them are very interesting. After checking the input values of the solar wind, I can tell you that the angle of field lines towards the vectors depends on this value, Bx. It was rather obvious. Anyway, if within the input data we will include the value of Bx component, the field lines will be tilted most of the time. This is why the SWMF real-time monitors simply ignore the Bx component. However, ACE satellite is measuring the Bx all the time, and you can watch its variations on the real-time graphs. Right now its value is around -2 nanoteslas, what means that the field line's angle is tilted again. But now it is time to start talking about the difficult things. You need to keep in mind that the environment of space likes to change quite often. During some more active time, the directions of field lines can shift couple times during 1 hour. And the directions of field lines in the IMF decide how will look the flux tubes which form within the magnetotail and discharge our planet. Just look at this one. According to my latest claims, this flux tube formed along the BX component of low energy field. And indeed, the particles move in this direction. But it's not always such obvious. As I said before, the directions of magnetic components change quite often, and in the matter of couple minutes, the angle of flux tubes can be totally different. So, as you can see, it's not that easy to point out the source of those disturbances. However, it is much easier when you know the rules according to which energetic particles behave. And energetic particles seem to behave rationally, guided by the magnetic forces which work as highways for them. Particles will always move in order of their energy bands and electric charge. Besides, fields with different directions of current flows will always separate from each other by creating barriers or sector boundaries. For example, on this image, the sector boundary is placed on the side of magnetotail. Particles separated by the red line won't mix with each other until there won't be a magnetic reconnection. Which will form a flux tube through which the particles will be exchanged between those two fields. I hope that it wasn't too complicated for you. It would be probably worse if I would start to talk about the fact that particles with opposite charges will always move in opposite directions. But I think that it is enough for today. Class dismissed. Peace.